When we look at question 16 from the homework, and we're looking at this greyhound design, this greyhound problem. Okay, so this is chapter 13, number 16. It says it's probably a matched design. So what is meant by that? Okay, well, we know that we have 3 treatments that we're giving to the dogs, right? And we're going to look at we're going to measure how fast they run on the track. How are we going to know if the diet worked? Faster than. So we are matching their response to their original. That's called a before and after design sometimes. Okay? So when I say matched pairs is one type of experimental design. Okay? And that means that we are looking at the treatment that's being given and we are measuring it against something. Oftentimes it's a control group, right? This control group didn't get the treatment. In this particular scenario, the control is themselves, right? Is the dogs, their own before they got the diet. Okay? So that's what the before is called a matched pairs design. Okay? And so we also can sometimes call that a before and after design. Either or is okay to say. But this happens when you compare to itself. Okay? Another way to say that is they act as their own controls. That happens a lot. Okay? So that's something to consider when you're looking at experimental design. Okay? Any questions about that? I'm not sure. We kind of briefly talked about it, but I don't think I emphasized it a lot last class. So it's kind of an important idea there. Any other questions from homework? If you didn't get that question right, are you okay with it now? Yes, no, maybe so? Hopefully. Okay. Let's go ahead then, if you would, and let's look at the multiple choice practice questions that I gave you. So I gave it to you as a handout. I want you to take a look at, and I apologize for the quality of this print job, okay? It's pretty poor. So I have it up here. It's a little bit better on the smart board, but because we're only given so many multiple choice for these questions, so it's kind of hard sometimes they're given to us as a PDF, so I have to take a snapshot because I don't have Adobe Pro, and here it is. All right, so stratified random sampling. I'm going to turn this down a little bit so we can see. Oh, that's a little better. So what do you think about this question? Anybody have a chance to look at it and answer it? Do you need some more time? Kind of? Okay, I'll pause the recording. You guys go ahead and talk about it. I want you to answer questions 1, 2, and 3. Okay? Let's see like we got our answers. Number 1, what'd you get, Isaiah? I did get C as well. So let's make sure here. It says, under which of the following conditions is it preferable to use a stratified random sample than simple random sample? Remind me what the difference is. Brenda, what's the difference? What's a stratified random sample?
Stratified is like, is being like, I know it's like a design language, like it's being like divided into like subpopulations or strata.
Okay. And when you say that, do we divide them into homogeneous groups or heterogeneous groups? Homogeneous. The people in the strata are like each other, right? So they're homogeneous. Heterogeneous sample would be a cluster sample, correct? Okay, so let's look at this. So let's look here. So it says, well, you just answered the question. So part C, because they're alike. You divide them into strata when they are alike. That is called a stratified random sample. Basically a definition, isn't it? Okay.
That is not to get to the way the strata.
Kind of. They all do though. Right? So it doesn't really matter. They all say strata. Okay, let's go ahead and look at number 2. What do you think about this one? Dana, what did you get for number 2?
I don't think I'm right sure.
E is right. Okay, that's what I got also. I also got E. Okay. Let's kind of go through the answer choices on this one though, and let's see what 2,000 received a survey, only 317 responded to that survey or returned it. So how could non-response cause the survey to be biased? Well, what do you think about answer choice A? What is wrong with answer choice A? A lot, I agree. But what specifically, Devin?
It doesn't reduce the sample size, for one, and then small samples and large samples are kind of similar.
Actually, if bias is present, when you enlarge a sample, the bias gets larger too, right? So large samples don't necessarily have less or more than small samples. The sample size doesn't really reduce bias. What does get rid of bias? Randomization, right? Okay, I mean, sample size has something to do with it, but if bias is already there, it just makes it, it magnifies it. All right, what do you think about letter B?
Would it be randomized? Like, would it be biased if everyone in the survey and like did what they were supposed to do?
Would that be bias? No.
Okay, so that's not.
The only bias this is non-response, because a whole bunch of people didn't respond to it. That's the only source of bias here. And the reason that it, and what is the problem with that, the type of response is non-response bias. Or you can, I would even go with voluntary response, because you could have argued that I chose not to respond, right? But if you're looking at the group as a whole, if you have a large group of people that didn't respond to a survey, well, why is that? Well, the people that chose to respond might have very local opinions, right, to the survey. They might really believe in this new high school or whatever the survey happens to be about. But those who didn't respond, or those who did, may differ, may have a different opinion than those who didn't respond, okay? So that's really the answer there. What is this assumption of independence? Not me either. Those who did not respond were indistinguishable from those who did not respond. Well, how would you know? Right? You can't really assume that either. Those who did not respond represent a stratum. Well, changing the simple random sample to a stratified random sample. No. Because if you're going from a stratified random sample, you divide them to begin with, right? And then you pick from each of the strata to send the surveys out. You can't get your results back and then divide them up. It doesn't work, right? You have to be careful with that. You divide them up first, and you see them. So E is the correct answer there. All right, let's look at number 3. George and Michelle, chocolate chip cookie people. You ever watch Cupcake Wars on TV? Yes.
Yeah.
What's that? Food Network, cooking channel. Find it. Okay, me and my daughter love to watch it. Even though I don't make it. All right. So let's look at this particular situation. Okay. And so Zachary brought up a point. He missed the word false. And you know what? Those are little teeny tiny words. And it's there. They tried to underline it, I think. Right? Sometimes they'll try to highlight it, bold it, or italicize it or something. But here we go. So, which statement is false? What did you get for this one? Which one is false? D is false. All the other ones are true. Let's see. George and Michelle have a different population of friends. Their sampling procedure makes it difficult to compare. Could be, right? We don't know who George and Michelle are. They might have different friends. I don't care. I don't know. They didn't ask the same people. Can't compare with different samples. Okay? Because George and Michelle each use their own respective recipes, their cooking ability is confounded with the recipe quality. True. What if one's a better cook than the other? But it's their own recipes. So there's two different things. You're talking about the recipe and the person cooking it. So there's a confounding variable in there. Okay? Something that's kind of messing with the results. You ideally would submit two recipes to a kitchen and have them cook it. One person cook both. That's what you want to happen. Okay? All right, so C, because George and Michelle each use their own ovens in their own houses, the recipe quality is confounded with the characteristics of the oven. If you do bake at all, not that I do very often, but I can make a box cake like there's nobody's business, which is box cake, or like some brownies or something like that. I'll bring them. You're really brownies are my favorite. Anywho, on the box, it'll always tell you like ovens may vary. So that's because it happens all the time. Okay, you have to be careful, especially microwaves do that a lot too. Because the wattages can be different, things like that. So I agree, C is a true statement. Let's jump to E, make sure it's true. George and Michelle each baked one batch. There's no replication. True, right? You ever make something and then make it again and it's totally different than for some reason you're not sure why?
Oh, yeah.
I hate that. Okay. I'm not sure why. What happened? All right. So let's look and make sure we agree why D is false. George and Michelle use the same questionnaire, guys. Their results will generalize the combined population of their friends. You can never do that. Ever. Well, I should say that ever. One case where that will happen. But anywho, we really don't want to take two different populations and combine them into one. Okay, unless they're matched somehow, and we'll do that when we get to match eventually, but not right now. But you should not generalize a combined population in this case. Not okay. So that's right. All right. I have two additional questions. You don't actually three additional questions. And let me tell you, these I don't know what happened, but I printed them so small. So they're going to be here, but they're up here. They're a little better up here. So I'm going to give you a copy so you can read as we go. Okay? So, Dr. Answer, it was not this time. Okay? Which would not be appropriate. Now, this format of question is an older SAT/AP format of type of question. They're kind of getting away from this format now, where you have three choices and you have to choose one and two, two and three, one and three, whatever. This is kind of an older multiple choice format. So I'm pleased to say that they're getting away from it, but I think it's still a good question. So let's go ahead and look at it, okay? So I'm going to say that in recording too. There are 40 multiple choice questions. You have an hour and a half to complete them. Come on, guys. So that's about a little over 2 minutes a question, right? An hour and a half, 90 minutes to do 40 questions, a little over 2 minutes. They are not all this long, okay? This would definitely be the longest or one of the longer types of questions. Yes. I'm not in the room. I'm not allowed to be in the room during the AP exam. Ms. Harris is usually the proctor. What I will say is that I am a proctor for IB exams, and I know for IB exams, Ms. Ellis always writes the time on the board. I don't know about that. I will talk to her and hope, I would assume that she would, but I don't know 100%. Anybody take a COCO exam? Do they warn you? Yeah. Okay, so then they will probably do that as well. I just can't be in the room. I don't know how many words. Okay. All right, so have we read this? What do we think? So let's read it here. So we do have an experiment. We're told it's an experiment, so at least we have that going for us. We don't have to make that decision. And we're trying to figure out whether or not aspirin can prevent heart attacks. Okay? When you read this, we're looking, since we know it's an experiment, we're looking for elements of good experimental design. Since Tanner and Temerson weren't here last class, let's remind them or tell them, what are the three, sometimes four elements of good experimental design? Jasmine, give me one of them. Replication, what does that mean? More than one and what? Each treatment group. Each treatment group has more than one. So replication, give me another one. Amanda. Control group. And sometimes people act as their own controls, right? So that would be a matched pairs or before-after design. But a control group is something you want to look for. And then a third one that really needs to be there is randomization, okay? So randomization, those three things really are essential for good experimental design. What do sometimes we look for? Blocking, okay? So sometimes we'll block by a specific trait with gender or age or something along those lines. So let's see if we can find those control group? Yeah, so it does say there's a control group. So let's see if we can identify all the parts. So it does say control group, so we're good. Is there replication?
Yes.
Okay, so we have 11,000 took aspirin, 11,000 treatment group. Is that good enough replication for you?
Not enough.
I think it's more than one. I think it's pretty decent replication. And then what's the third one? Randomization. So is there randomization here? It's not mentioned. Okay, it's not mentioned about randomization. So we don't know if the physicians came to us and we said, oops, you're going to take this pill, you're going to take this one, and they don't know. A good question is from Deja. Is it blinded? Do they know whether they're taking aspirin or placebo? I don't think it mentions here either, right? So, it's missing something. Would you agree with that? Okay, so let's go through and see what else we see. So, which of the following statements explains why it would not be appropriate to say that everyone should take aspirin every day? Okay, so let's go through here. The study included only physicians, and different results may occur in individuals with other occupations. Would you agree with that? I would. Do you know many really unhealthy doctors? Not many. For the most part, doctors are pretty healthy people because they've done a lot of studying about what things can go wrong with the body, right? So I think that one is probably a true statement. Wouldn't you? Yeah. Let's see. The study included only males, and there may be results for females. Yeah. Agreed. Because you really should block by gender, because we all know that males and females have different responses to different things. Okay? Although taking aspirin may be helpful in preventing heart attacks, it may be harmful in some other aspects of health.
We all know.
True? Okay, that can be a true statement too. If you, for example, my grandfather should never take aspirin because if he cuts himself, he will bleed to death. There's a name for that. You know, he's not a hemophiliac, but it's closely related. So he can't be on blood thinners for that reason, right? So that's something you have to be real careful of. So it could be harmful in some other aspect of your health. So I agree with that too. Question.
All three of them have the word may in it.
And guess what? This is what is so almost kind of irritating about statistics. It is so vague all the time, and the language is there on purpose.
Because if there's the word may, then it's all of them will be.
Not always, but I agree with you.
There's always the possibility of something not being
Likely, may, could be. I agree.
Nothing can be like that absolute.
Nothing will be absolute in statistics, ever. And that's something that's frustrating a little bit, and I agree with you. But the language, the word may is in there for a reason. I agree. Okay, 1, 2, and 3. We good? All right, let's look at the next question. Did you have a chance to look at that one yet? I'll pause the recording so you guys can look at it. All right, so let's go through each one of these and decide what kind of a sampling method they chose here. Survey the first 60 students to arrive at the school. What is that? Nope. Convenience sample. And y'all know I can't spell that.
To be fair, neither can I.
Pretend it's right. It's convenient. I don't know.
Close enough. It's close enough.
Right. Every 10th student entering the library, systematic. And not only that, systematic in itself is not bad. What should we do to make it better? Randomize starting point. Good. Letter C, use random numbers to choose 15 of each first year, second, third, whatever students. Stratified random sample. Still not at our SRS, correct? You're going to have a test coming up on, I see next Monday, on next Thursday. Okay, next Thursday your test, and we'll cover all of what we're doing today. Okay, and then we're going to do a practice test next class. Your test on Monday, your test on Thursday. All right. Now, this is something. Letter D is something that a lot of people use as a way to collect data at the end of the year projects, because you guys are going to have to actually do some data collection at the end of the year. not an SRS, but what is it? It's a multi-stage sample, okay? Because the first stage is to number the cafeteria seats and randomize which, so the first stage is to number the seats. The second is to randomize the chosen seats, and then we go from there. So it's kind of like a multi-stage step process. That makes any sense? It's kind of close to an SRS, but what's the bias it suffers from?
Not everyone is.
Say it louder, Maddie.
Not everyone knows the cafeteria.
I mean, let's cafeteria. I think it matters. And if it's going to be a true SRS, every single person in the population has a chance of being selected, right? In that case, it wouldn't. What you got, Sandy? Louder. Your opinion matters. Louder. So, like, what if you only go to B lunch? Right? I go to C lunch. I'm mad at you because I wanted to be included. So, yes, I agree. So, this is not going to be an SRS, but hopefully E is it?
Yes.
Okay. Number of the students on the official school roster, so you've included every possible student. Use a table of random numbers to pick 60 from there. Perfect. Got it. Done. So, that is your true SRS. Excellent. All right. If you would now, go ahead and flip over the first page I gave you. Oh, I'm sorry, there's one more question. I'm sorry, I forgot. Sorry. Amanda.
Is there something you need to say from the AP exam? Like, is the question that answer the question is wrong or the question is good?
Okay. I will address that because I was an AP reader this summer. In June, I went to Kansas City and graded. Do you mean a multiple choice or do you mean a free response? We only grade free response. Multiple choice obviously is just scan. And those questions, there are the process by which a multiple choice section of a test is put together. You need something. Don't go because you have a new investment. Watch the recording to hang on, take my picture. Ellen is here. Sorry. Okay. Go back into your question, okay? The process by which multiple choice questions are selected to go on an official AP exam is very rigorous, okay? They go through a test trial period where they will be put on an AP exam and not counted, and they will just look to see, what were the people's choices for answers, maybe the wording was wrong. So that all is a process. So by the time it gets to you on an AP exam that it's going to officially count, it's gone through a whole process to get there. So they try to go through all of that to eliminate bias and wordings of questions being odd and things like that. Now, when it comes to free response questions, because those are not reused and they're different from year to year, there is a panel of college professors that put together what we call a grading rubric, okay, for each question. There's what we call a question leader, and then based on the question leader, there is a panel of other professors that get together that look at all the different possible responses they can think of at how a question would be answered, and they go through that. They get there the week before that the teachers get there to grade, and they put together their grading rubric. And they go through that for several days, and then they go and teach us how to grade the exam. Now, I will tell you that the rubric can be tweaked a little bit even after we get there, but it goes through a multi-day process to get it correct. And so, I don't know if I answered your question or not. Did I? Kind of. Okay. I don't remember the question was, but remind me. What did you say? What was your question? Remind me. Yes, there can be errors, but they will be fixed. Sometimes a question gets every FRQ gets graded by 3 different people. So
if you get it right, 2 out of 3 people get it right.
The question leader gets to make the decision. There's a table leader, a question leader. It goes through a process. It's very complex. Exactly, and that happened to me last year. I ended up getting one of my students, believe it or not, out of 700 and however many thousand tests, I got one of my students last year. I'll tell you who it is. I can't tell you who it is, but I couldn't grade it. I mean, I had to give it to somebody else to grade it.
Would you have graded soccer?
No, but I wouldn't, and honestly, the only reason why I knew it was him is because he was school code, and you have to put like the first few letters of your name, and anyway, long story. Let's move on. Okay. Number 8. You should know this. I just said it. What is it? B. It's the only one. You said at the very beginning of class, right? Oh, highlighting the wrong one. Only a well-designed experiment with a control group would in fact would show a cause and effect relationship. All right, so problem. This is the one you have. Is this correct? The fish tank problem. You should have it on the back of one of the sheets I've given you. I'm going to turn a light back on so you can read it. I do think this one printed out a little better. So I want you to read the problem. And if you actually look at the bottom, the question says, design an experiment. So I want you to do it. Okay? I'm going to give you about 10 minutes because that's all the time you would get, really. About 10 minutes per FRQ. Okay? So that's what I want you to do. You have 10 minutes, and then we'll go over the answer. Starting at minimum, you should say something to the effect of control. This is my control. This is my whatever. You need to make sure that at minimum you are telling me something about each of the 3 elements. As a hint, you should take into consideration the windows and the doors and the heater. They will affect the temperature of the fish tank. So that was 10 minutes. Okay, so kind of get a feel for what that felt like. Now this question was given on the 1997 exam. It was the first exam that was ever offered in AP Statistics. Okay, we've never had one like this since that's purely an experimental design question. Okay, it's been an experimental design has been combined with some other things. There's another one called bird deterrent that we'll look at maybe next class. That was on a more recent exam. What I like about this question, though, is that it's true experimental design. Okay, there's nothing else but that. So that's why I like to look at it in this particular situation. What we need to do is we need to address how we're going to randomize and how we're going to use control and all these other issues. Okay? So, let's first think about control group. The control group, and this is what Monica and I were just talking about. There are only 2 treatments, the new food versus the old food. The old food is like the control group because you're comparing a new treatment, a different treatment, to something that's already existing. Okay? So there is no control group in the sense of they get no food because that would just kill the fish. And that would be sad.
For the chances that they get like no water.
But because water has to be given, we really probably should have said the amount of water they're currently getting versus a new amount of water, okay?
Oh, wait, so what would the control be?
The old food, yes. The old food is we're going to treat that as a control. So let's listen now. If you look at the way that the tanks are organized here, I'm going to group, actually I'm not even going to group, I'm going to pair some tanks. Do you agree that tank 1 and tank 4 have similar exposure?
Yes.
Because they're both near a window. Do you agree that tanks 6 and tank 7 also have similar exposure? Because they're both right in front of the heater. So I'm going to pair, I'm just coloring them in, but these are, because I can't move the tanks, they're cemented to the ground, I'm going to pair 2 tanks together that are as like conditions as possible. Because I don't want there to be any confounding variables that might come into play. I want to try to treat them as much alike as possible. So that's what I've done. So somewhere along the line you should say that. You need to say that. Okay? How do you say that? All you really have to say is this is going to be a matched pairs design because you are matching 1 and 4. You are matching 2 and 3. 6, and 7, and 5, and 8. We are matching them because these tanks have similar conditions in the room. We haven't got to either one yet. It's kind of like blocking. I'm doing that first. I am blocking by the location in the room. So this would be the blocking part. You always need to block first if you're going to use blocking. Okay? So we'll address blocking this way. So we're going to block by location. Enough? I don't think that would be enough. Okay, I think because symmetrical, like some people would have divided it into this quadrants like this, which would be wrong. If you divide it into quadrants, 1 and 2 do not have similar conditions. Do you see what I'm saying? So if you say symmetric, you see that I mean that's not. Because I don't know what symmetric means. To me, symmetric means that. I think you have to be as specific as possible and say 1 and 4 are matched, 2 and 3 are matched. So you have to be very specific.
If we say blocking by temperature?
Fine. Because they are, as long as you tell me that you put 1 and 4 together, 2 and 3 together, that's fine. Okay. Because windows, doors, and heaters all affect the temperature of the tank. Good enough. So we've addressed blocking. What else do I need to address? Randomization. Okay. How am I going to randomize who gets what food? Does it matter? Okay. Well, I'm going to pick, I don't care. Do I just randomly pick the first one and that comes up? And there's only 2, right? One gets it, one doesn't. So my randomization process can be, I'm going to randomize who gets the new food, right? If you are an odd number, you get the new food. Would that be random? Sure. Doesn't matter, really. But you have to pick some kind of process in which the new food is chosen, okay? So you can say I use a random number generator, and if 1 came up first or 4 came up first, they got the new food. I don't really care how you say it, as long as you tell me your randomization process. Which one got the new food, okay? So, I don't know, we'll say odds get the new food. Because there's an odd and an even in each pair, correct? Okay, so odds, new food. Right? So we have new, 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 and new. Good enough? The old food is our control group. We've already talked about that because we're matched pairs. So we've talked about blocking. We've talked about randomization. We've talked about control. What's the last one? Replication. Is there more than 1 in each treatment group? Yes. So I've addressed replication as well. Are we good so far? Okay. So what am I going to do to kind of follow up with this? How would I, once I decide who gets the new food, who gets the old food, what am I going to look for? After so many weeks, months, I don't know, how long do salmon eat? After, just say 6 months?
Yeah.
Okay, so after 6 months, what am I going to do? Change the fish, see which one tastes better?
Yeah.
I understand. Does it say what we're looking for the response variable to be? Let's see. The weight gain. So we have to mention that. Your response variable must be mentioned in your conclusion. Okay? So the response variable is weight gain. So what are we going to be looking for? Which in each pair, right? Which one gained the most weight? And that would be my conclusion. Okay? So, conclusion, compare each matched pair and decide who weighed the most. Measure the weight gain of each. That's it. That would have been enough to get full credit on this particular question. Okay? All right, we only have about 10 minutes left. Let me give you already have your homework. It is an investigative task. It is due Monday. Okay? So let's talk about it. So you have the weekend and you have tomorrow. Okay, so I know everyone on a Friday night is going to be doing their statistics homework. Okay, hopefully we'll be sleeping. Anywho, can you guys please read this for me? Because I need to address a couple of things as a class. Because these are some issues that have come up in years past when I've assigned this. So please read just the heavy equipment manufacturer introduces. Please just read that for me. Went in the Good. So, you are being asked to design an experiment, okay, that uses a new additive to the hydraulic fuel additive, and you need to decide whether the additive has made a difference. So it is an experiment because the treatment is the additive, okay, so it is an experiment. You need to do a well-designed experiment, so you are going to have a control group. What will the control group be? People that don't get the additive. People, not people. Who are the subjects of this experiment? The actual machines. Here's an important part. You listening? There are two types of machines. What does that mean? That means that you have to do what with experimental design? Use the correct vocabulary. Someone said it. Block. You have to block. Okay? You have to block by machine type because you have forklifts and you have backhoes which may respond differently to the treatment. That is important. Okay? What you're going to need to do, and I'll answer your question in just a second, you need to design your experiment in words, and you need to draw me a diagram. What do I mean by diagram? I mean you're going to do this thing. And you're going to put numbers in, the word random in, kind of like what we did last class. So you will just, and you remember how we looked at, you know, does that make sense, my picture? It should, okay? You're going to put words and numbers in it, but you'll add that, okay? So number one, let me finish and I'll answer all questions. Number one, you're going to clearly design the experiment in words. So you're going to tell me, I am going to block by blah, blah, blah. I am going to use blinding if you are. I'm going to use control in this way. I'm going to use replication in this way. Okay? You need to talk to me about all the elements of design in number one. Number two is the picture. Number three, perform the randomization procedure. So you need to tell me the outcomes of however you choose to randomize. I am okay with you using a calculator to do that. So you're literally, if you're going to, I'm just making something up, you're going to randomize from 0 to 4. You would do right on your procedure to randomize what treatment group this particular forklift went in. I had to do this and this. Are we okay with what I'm saying? I'll say it one more time. Because you randomize what treatment group they go in, you have two treatment groups for each block. Would you agree? Forklifts either get the additive or they don't. Backhoes get it or they don't. So how would you randomize? There's more than one way to do that. Okay? So understand what I'm saying now? Hopefully. Explain your process. Then it says, talk about bias. What could, you need to have a bias discussion, which means a couple of sentences, a paragraph or so, about what kind of bias may result. Okay? How are you going to measure, like what's the response variable? What are you measuring here? The time it takes to make a repair. Okay? That's a response variable. You're trying to shorten that. Would you agree? So, what kind of bias might be a result of that? People could lie. People could forget about their backhoe. The forklift could be left out in the rain. I don't know. People put it in wrong. There could be lots of things, right? But discuss that. Use vocabulary. sentence. And Deja, say it again loud. What are we measuring? The time it takes to need repairs. That needs to be in your conclusion. Okay? So the adjective works if it takes this long. I don't know. You tell me. The conclusion, how long is it what you said? It doesn't matter. A couple sentences. As long as you are talking specifically about the response variable. There is a grading rubric on the back, like they have been for every investigative task. Okay? It's only homework. Question, Erica. Shh. Guys, listen. They either get the adjective or they don't. The people who don't is the control. Yes. Yes. Within the block and to each block. Anybody else? Question? No? All right, you have your homework.